As you can see from the title of this video, this tutorial is about performing a simulated lab experiment. So what I have up here is a series of lab steps and some data that was obtained that you would have gotten had you performed a empirical formula type lab or molecular formula type lab right before you would have sat down to take the test. So what we're going to do is we're going to take this laboratory data and I'm going to show you how we can use data from the lab to ascertain pieces of information we need to find a useful bit of information that will allow us to solve a problem. This is one case where it really is much simpler to print out the copy. I have this up here and I'm going to read through it, but I'm going to make it go away because it makes the video very difficult to see. Simulated lab. It says, complete the data table and answer the following questions. Show all work, units, and calculations when necessary. A small amount of pure nickel was placed in a clean, dry crucible whose mass was known. The crucible was heated so that the nickel would react with the oxygen in the air. After the reaction was complete, the crucible was allowed to cool and the mass of the crucible and the contents were determined. The following data was collected. Now in the lab we would get more specific. This would be heated and reheated till we hit a constant mass. Right? But for the purposes of this simulation, here is the data that we have. Right? Here we have the mass of the crucible and the cover. It's 28.08 grams. Here is the crucible, the cover, and the nickel, which is 32.28 grams. Some questions I want to know is what is the mass of the nickel used? How many moles of the nickel was used? I've given you the mass of the crucible and the contents after heating to a constant mass. And then I would like to know, what is the mass of the nickel oxide compound? What is the mass of oxygen that reacted? How many moles of oxygen reacted? What is the empirical formula of the nickel oxide? And what would be the name of that empirical formula? The reason being is nickel has the ability to carry multiple charges, so we don't know what its formula is by simply doing symbols and charges and crossing them. Right? Nickel could be a +2, sometimes it's a +1, it can form complex ions, all sorts of things. So we're going to try to get ourselves an empirical formula and then name it. Right, so I'm going to take this away and we'll bring it back up as needed. And the first thing that they want us to find, right, is the mass of nickel used. So we'll jot that down over here. So if I'm going to get the mass of the nickel, right, what I need to do is use the information at my disposal. And it looks like I've been given the mass of the crucible, the contents, right, before we heat it, and the mass of the crucible, the contents, after we heat it in an empty crucible and contents. So on that data sheet that you were given, one of the things is the mass of the crucible and the nickel. And if I want just the mass of the nickel, what I need to do is subtract out the mass of the crucible and the lid. And this had the lid as well. Right? So if I have the crucible, the lid, and the nickel, and I know what the empty crucible and lid is, the difference between those must be the amount of nickel that we put in. So if we bring our numbers back up to see what those were, you'll see that the crucible, the lid, and the nickel was 32.28 grams. the crucible and the lid all alone was 28.08 grams. Which means the mass of the nickel will simply be the difference between these two. Only thing you have to watch out here for is sig figs. 32.28 goes 2 past, 28.08 goes 2 past. So even though my calculator is going to tell me 4.2, I have to make sure it goes 2 past when I say 4.20 grams of nickel. So that's how we get letter A. That is the mass of the nickel used. We simply subtract out the mass of the crucible and the lid. Letter B wants us to get the moles of nickel used. So if I'm going to get the moles of nickel, that's pretty straightforward. Anytime we have grams of a substance and we want to get it to moles, it's a one-step bracket problem using the periodic table. So we'll start with our 4.20 grams Ni, and then we're going to do a bracket problem to convert grams to moles. So grams Ni on the bottom, moles Ni on the top. 1 always goes with moles. I would go to the periodic table and get nickel, which I feel like is 58.69, but we'll look. 58.71. Grams of nickel will cancel. We'll be left with moles of nickel. From here, simply doing the math problem, so you take out your calc. 4.20 divided by 58.71 is 0.071538. We get 3 sig figs, 4 sig figs, so 3 in my answer. So 0.0, and remember that doesn't count because we haven't hit a non-zero yet. 715, and the 3 after the 5 is not going to round anything up. So we have 0.0715 moles of nickel. And just to give you an idea about why we're proceeding through these steps, if you think about how an empirical formula problem works, that's the end goal. Right? We always want to get grams of each element, then convert them to moles, then divide by the least, and then get whole numbers. Well, what we just did in our first 2 steps was got grams of nickel and converted it into moles. Right? No surprise that if you take a look in the next couple steps, we're going to try to do the same thing with oxygen. We'll get the mass of the whole thing, the mass of oxygen by itself, moles of oxygen. All right, and then we'll be ready to get the empirical formula. All right, so C says we want the mass of the nickel oxide compound. So if I want the mass of the nickel oxide, the first thing you have to understand is where is the nickel oxide located? Right, if we take a look in our experiment, it says that the crucible was heated with just nickel in it, and it reacted with oxygen from the air. So after the crucible was done being heated, oxygen from the air underwent a particular type of reaction called a synthesis reaction, that it bound to the nickel inside the crucible. So where the nickel oxide is after the heating. So the mass of the crucible and contents after heating is the nickel oxide. So if we want just the nickel oxide, we need to take the crucible, the lid, and the nickel oxide minus, no surprise, if I have nickel oxide with the crucible and lid, and I want the nickel oxide, we have to take away the crucible and the lid. And that will be the grams of the nickel oxide. Getting the numbers that we need, right? The crucible, the lid, and the nickel oxide is the 34.60. And then just like before, the crucible and the lid by themselves are 28.08. So unplugging that just in case it was having trouble seeing it. Crucible, lid, nickel oxide minus the crucible and the lid will give me the mass of the nickel oxide. The 3460 was the mass of the crucible and the lid after heating, which is when it has the nickel oxide, taking away the crucible and the lid. Right, so same thing as before. You're adding and subtracting, so you care about places past the decimal. So 34.60 minus 28.08 looks like we get 6.52 grams nickel oxide. Now, that particular step was there to help us with the next step, because the next step, letter D, wants the mass of oxygen. Well, in an experiment where the oxygen came from the air, how is it I'm going to know how much air entered the crucible and how much did not? Well, we have to take a look through process of elimination. We have to find something that possesses the oxygen, and then again, something that does not possess the oxygen. And from that, we can subtract to figure out how much oxygen was added. So to get our mass of oxygen, what we are going to do, right, is take the crucible, lid, and nickel oxide, which has oxygen, minus the crucible, lid, and the nickel. Right? Because if I have the crucible, lid, nickel oxide, nickel and oxygen, and I take away the crucible, the lid, and the nickel, all that's left is the oxygen. Right? That's one way to do it. Right? The second way to do it would be to eliminate the crucible and the lid. Right here, you have just the mass of the nickel oxide. Right here, you have just the mass of the nickel. Well, the difference between those is also oxygen. So I'm going to list two separate ways that you can get yourself to the oxygen, and you can choose which one makes the most sense to you. I'll never force you to solve a problem one way. So here, we'll just take the nickel oxide minus the nickel, and that will be the mass of oxygen. And as was here. Right, so let's do the crucible, the lid, and the nickel oxide first. The crucible, lid, and nickel oxide, which is still on that paper, was 34.60. grams, minus the crucible, lid, and the nickel, which I'll just pull from here, but it's on the top line in your sheet, 32.28 grams. And the difference between those will be the mass of oxygen. So 34.60 minus 32.28 is 2.32 grams, and we go two places past the decimal. If I do the same thing using our alternate method, right, the nickel oxide was 6.52 grams minus the nickel, which was 4.20 grams, and no surprise here, ends up being 2.32 grams of that. So both of those ways are perfectly legitimate for getting yourself your mass of oxygen. There are very rarely only one way to get yourself to information that you need. So choose the way that makes the most sense to you. Either way, we just got ourselves our mass of oxygen. And then the next step in this was they wanted us to get the moles of oxygen. Now, no big deal here. We have grams of oxygen right there. 2.32 grams of O. We want moles of it. That's a one-step bracket problem. Grams of O on the bottom, moles of O on the top. Off the periodic table, 16.00 grams of oxygen. So we take our 2.32 divided by 16.00, and we get that there is 0.145 mole of oxygen. So now we're to letter F, which wanted the empirical formula. Now, I could simply ask a question that said, what was the empirical formula? And you would have had to figure out that you need all of these things. In an empirical formula, I have to get mass of each element. So we got grams of nickel, and we got grams of oxygen. You would have also said, step 2 is converting those to moles. Well, sure enough, here in B, we went grams to moles and got the moles of nickel. And in step E, we went grams to moles and got moles of oxygen. So the idea here is we just took a longer empirical formula problem and broke it up step by step to try to figure out what is going on. So we're going to use those bits of information. Okay? I know that my moles of O is 0.145. And I know that my moles of nickel is 0.0715. The next step in an empirical formula problem is always to divide by the least. So the 0.0715 is the smaller of the two values, and you get yourself whole numbers if possible. So right here, no big surprise, 1.00 mole Ni. Here, 0.145 divided by 0.0715. That is 2.027 with 3 sig figs is 2.03 mole of O. Then you would say, are these close enough to whole numbers to write ourselves a formula? And the answer is yes. 1.00 is very close to 1. 2.03 is very close to 2. So my empirical formula would be NiO2. So, the last thing that it wanted us to do in step G was determine the name of this compound. So if you look at this nickel-oxygen compound, looks like we have a metal in nickel with a non-metal of oxygen left of the staircase, right of the staircase, which means it's an ionic compound. And remember, with ionic compounds, right, we don't use prefixes, right? So we'll say that this is a nickel oxide, and then we have to check if nickel is a transition metal, it gets a Roman numeral. Right? Well, sure enough, nickel is a transition metal. It's in between groups 3 and 12. Right? So we need to figure out the Roman numeral for this. And the first thing we always try to do is uncross the charges. So if we uncross them, all right, it puts a 2 on nickel and a 1 on oxygen. If that makes the charge on O correct, you're done. You know that it would be. However, O is a -2, and when we uncross it, it says that it should be a 1. That means we have to break the compound down. So NiO2, break it in the middle. You take the number of O's, 2 times O's charge, -2, means that side is a -4. This side has to be a +4 to cancel. I only have 1 nickel, so what has to be the charge on that nickel to make that statement true? X has to be +4, which means it's a Roman numeral IV. So the name of that compound would be nickel IV oxide. Depending on the year, I will do these in different orders. I'll do the math, empirical, molecular, percent comp first, and we won't know how to name compounds. So if this looks odd to you, because we haven't covered compound naming yet, don't worry about it. All right? And in some years we do the compound naming first, and then we come back and do this, which means this should be old hat, so to speak, in that you already know what you're doing. I hope this helped out with the lab simulation scenario, whether you're working on a lab report or getting ready for the quiz or test that is coming up. As always, if you're still having trouble or confused, please come in for some help.